I will first try this link in my own browser. And as we can see, the cookie has been extracted. In this defensive challenge, I'm going to explore 3 approaches that we can use to address a security defect. Let me first run this app to explore its functionality and a way to exploit it. It accepts a query parameter name and it will echo that value back. A recipe for cross-site scripting. Let me try a proof of concept here. I enter a script tag, and as I can expect, this script got executed. Let me walk through a more meaningful exploitation here. I will register an endpoint. Let's just call this an attacker server that I can monitor the incoming request with. Now I will change the input to something else and will generate a link that anytime I send this link to a user or a victim, their cookie will get extracted and will be sent to that server that I control. I will first try this link in my own browser. And as we can see, the cookie has been extracted. Let's patch this. A common way to address XSS is output rendering. Now, this approach that I'm using here is a spot patching where this field is being rendered in the HTTP response by using the escape function. And this escape function will escape those dangerous characters. Let me try the same proof of concept as before. And those HTML characters are escaped now. As you can imagine, this way of patching is not scalable, especially in a large code bases when we are dealing with lots of fields. At the same time, it's open to mistakes, and we cannot go after every single field and try to escape them. This will bring us to our next approach in addressing a security defect. In this approach, I will follow a secure by design principle. I will remove all instances of raw HTML responses and replace them with the output from a template engine. Most server-side template engines, they perform escaping of dynamic HTML content. In our case, the name field that comes from an untrusted source, when it is passed on to a template engine, in this case, the default template engine from Django, the template parser will perform escaping of those HTML characters. What I need to do here is that I need to define the template, and later I need to provide those fields or dynamic content as a context to this template engine so the parser will do the job. Now, one thing we should remember, we should never concatenate these fields or untrusted fields or parameters or dynamic content to our template. Otherwise, the template parser will not gonna help us. But most importantly, this will also introduce another more severe security issue that I will talk in the future. I will here do some configuration change to specify where my templates are. I will also go and define a template for other endpoints that I have within this app. So this is for the index. I will get rid of the raw HTML response here and replace it with the template engine render function. And another place is here where there is no name query parameter. I will run the app and try the same proof of concept as before. And as we can see, everything is escaped. I will now run the security test and usability test. Now, is there anything else I can do to improve my security approach here? Yes, there is, which is not specific to cross-site scripting, but is that I can enhance this security approach even further. I like to call my third approach in addressing a security defect secure by default. And the reason for that is we are going to refactor the code to enforce the security checks by default. I will borrow an idea from domain-driven development, which is called value object. And here I will define a name class or a name value object, which will enforce what I mean by name. If you think about it, in my current code, the name is a string data type. A string data type can be anything from bunch of ASCII characters all the way to whatever you can find in Unicode. This clearly is not what I mean by name in my app. So let's just restrict it. So in this case, as you can see, I will enforce some rules. And one of them is that the name field in my code is alphanumeric characters. And I will put this check within the constructor. So anytime this class or object is initialized, this rule will apply. And if anything deviates this rule, I will raise an exception. Now let's go back to the app and change anywhere that we have used name and replace it with this name value object. I now harden this value object a bit more by making it immutable. I will talk about the immutability in future. Now let's run the app and see whether it can function as expected, and also it can address the security defect. Let's give it the same proof of concept payload. And as expected, it raised an exception. The beauty of this approach is that all my security rules are in one place. So let's say I want to now limit the name to 10 characters. I will go to the same value object and add this rule. Now, the beauty of this is that I know when name exists in my app, it has been already validated. So I don't need to worry about validating name at some point. With regarding to the XSS, there are other things that we can do to harden the app. But my objective here was to talk about pros and cons of these three approaches for defensive programming.